Howdy folks, Crixus here. When we look up at the night sky, it's natural to feel overwhelmed. Millions of stars, swirling galaxies, and vast distances. It's enough to make a fella feel mighty small. But tonight, we're going to narrow our focus a bit. We're going to take a look at our own neighborhood. We're going to explore the closest stars to our home, Earth. So, get ready for a cosmic adventure. By the time we're finished, you'll never look at the night sky the same way again. Our sun might seem like the Lone Ranger of the Milky Way, but trust me, it's far from it. We're surrounded by a whole host of stellar neighbors, some closer than others. Now, when I say close in astronomical terms, we're still talking about distances that are hard to wrap your head around. Imagine this. The fastest spacecraft we've ever built would take tens of thousands of years to reach even the nearest star. It's a long trip, that's for sure, but that doesn't mean we can't study them. Using powerful telescopes and some clever techniques, we can learn a great deal about these celestial objects. We can determine their size, their temperature, their composition, even whether they have planets orbiting them. And just like our ancestors used the stars to navigate the seas, we can use these nearby stars as a cosmic laboratory to learn more about the universe as a whole. So buckle up, space cadets. We're about to embark on a journey through our cosmic backyard. From the fiery red dwarf Proxima Centauri to the majestic binary system of Sirius, we're gonna meet some fascinating characters and uncover some truly mind-blowing facts. Hold on to your hats, folks, because this is gonna be one heck of a ride. Let's start with our famous neighbor, the Alpha Centauri system. It's a trio of stars dancing in a cosmic ballet. Alpha Centauri A, a bright, sun-like star. Alpha Centauri B, smaller and cooler. And Proxima Centauri, a dim red dwarf, just 4.37 light-years from Earth. For comparison, if our sun was a basketball in New York, Alpha Centauri would be a golf ball in Central Park. Alpha Centauri A and B are in a tight gravitational embrace. Proxima Centauri orbits at a greater distance. In 2016, astronomers found a planet orbiting Proxima Centauri. Proxima Centauri B, Earth-sized and in the habitable zone. Now, ain't that something? Now, wait a sec, Space Cadets. Just because Proxima Centauri B sits in the habitable zone don't mean it's a second Earth. In fact, this planet faces some serious challenges. Being so close to its star means that Proxima Centauri B is likely tidally locked, with one side perpetually facing the star and the other shrouded in eternal darkness. On top of that, red dwarfs are known for their powerful flares, bursts of radiation that could strip away a planet's atmosphere. Proxima Centauri B is still a prime candidate for hosting some form of life, even if it's just microbial. It's a tantalizing glimpse into the possibilities of life beyond our solar system. So keep looking up, folks, because there's a whole lot more out there waiting to be discovered. Now let's mosey on over to our next door neighbor, Barnard's star. This little fella is a red dwarf with a few tricks up its sleeve. It's the fastest known star in terms of proper motion. Barnard's star zips along at 500,000 kilometers per hour. This makes it a popular target for astronomers. It's one of the most observed red dwarfs in the sky. For decades, astronomers thought Barnard's star might be home to a planet. They observed tiny wobbles in the star's motion, suggesting that an unseen companion might be tugging on it. These wobbles were tantalizing hints of a world orbiting another star, and astronomers were eager to confirm their suspicions. But alas, it wasn't meant to be. More recent observations with more advanced telescopes have cast doubt on the existence of this planet. It seems that the wobbles were likely caused by activity on the star itself, like star spots or flares, rather than the gravitational pull of a planet. Now, I know what you're thinking. That's a real shame. But don't despair just yet. Just because we haven't found a planet around Barnard's star yet, doesn't mean there isn't one lurking out there. It just means we gotta keep looking. And who knows? Maybe one day we'll develop even more powerful telescopes that will finally reveal the secrets of this speedy little star. Until then, Barnard's star remains a fascinating neighbor, a constant reminder that the universe is full of mysteries waiting to be unraveled. Meet Wolf 359, a faint red dwarf star. It's so faint, you'd need a powerful telescope to spot it. Just 7.9 light-years away, it's a true lightweight. Only 8% the mass of our Sun. Known for dramatic flares, releasing immense energy. These flares occur when the magnetic fields of a star get tangled up like a bunch of Christmas lights after a holiday party. When these fields snap and reconnect, they release a tremendous amount of energy, heating the star's atmosphere to millions of degrees and sending out a blast of radiation across the cosmos. Now you might be thinking, Crixus, that sounds mighty dangerous. And you'd be right. If our Sun were to unleash a flare as powerful as some of the ones we've seen from Wolf 359, it could wreak havoc on our planet, disrupting communications, frying satellites, and potentially even harming life on Earth. But don't go running for the hills just yet. While Wolf 359's flares are impressive, they're also relatively rare. And even if one were to occur, the chances of it being aimed directly at Earth are pretty slim. It's like winning the cosmic lottery, but not in a good way. Still, the study of Wolf 359's flares provides valuable insights into the behavior of stars and the potential hazards they pose to planets like our own. It's a reminder that the universe is a dynamic and sometimes violent place, and that even the faintest of stars can put on a dazzling, if somewhat dangerous, display. Well, we're moseying on down the cosmic road now to a star that's a bit of a wallflower. But don't let that fool you. Lalande 21-185, as it's known in the astronomy books, might not be the flashiest star in the sky, but it holds a certain charm. It's a red dwarf, like some of its neighbors we visited, but this one's got a bit of an old soul. Lalande 21-185 is one of the oldest stars in our galactic neighborhood. Astronomers reckon it's been around for billions of years. Now that's what I call seniority. Imagine the stories this star could tell if only it could talk. It's been witness to the birth and death of countless stars. At a distance of about 8.3 light-years, Lalande 21-185 is practically our next-door neighbor. But don't go packing your bags for a visit just yet. This old-timer is pretty faint, shining with only about 0.5% the luminosity of our own Sun. You'd need a decent telescope to even spot it from your backyard. But don't let its faintness fool you. Lalande 21-185 has been a favorite target of astronomers for decades. It's a relatively close and well-studied red dwarf, which makes it a valuable laboratory for understanding these fascinating stars. And you never know, this old dog might just have a few more tricks up its sleeve. One of the big questions surrounding Lalande 21-185 is whether it has any companions. Most stars aren't solitary like our Sun. They prefer to hang out in pairs or groups, bound by gravity. Astronomers have searched for planets around Lalande 21-185 for years. There have been tantalizing hints. In the 1990s, a Wobble suggested an unseen planet, but further observations failed to confirm this. The Wobble was a cosmic mirage. But don't lose hope, space enthusiasts, the search is far from over. With new telescopes, we're getting better at detecting elusive worlds. Maybe one day we'll find a whole planetary system. Until then, Lalande 21-185 remains a tantalizing mystery. Keep your eyes peeled, because the universe is full of surprises. Well, now let us visit a real celestial celebrity now. It's the brightest star in our night sky, shining like a diamond. I'm talking about Sirius, also known as the Dog Star. You can't miss it on a clear night. Look for the constellation Canis Major, the big dog. Sirius is just 8.6 light-years away. And just like a king, Sirius has a certain charisma. It's a main sequence star, bigger, hotter, and brighter than our Sun. But here's the kicker, folks. Sirius ain't alone. It's got a little buddy, Sirius B, a white dwarf. Now, the story of Sirius A and B is a tale of two stars, a cosmic dance of life and death. Sirius B wasn't always a dim, shrunken dwarf. It used to be a big, bright star, maybe even bigger and brighter than Sirius A is today. But as it aged, it burned through its fuel and eventually went out with a bang, expelling its outer layers into space and leaving behind a dense, white-hot core. Now, this white dwarf might be small, but it's still incredibly dense. Imagine squeezing all the mass of the Sun into a ball the size of Earth. Even though Sirius B is a mere shadow of its former self, it still exerts a powerful gravitational pull on Sirius A. These two stars are locked in a cosmic waltz, orbiting each other every 50 years or so. By studying Sirius and its companion, we might unlock even more secrets of the universe. We're about to venture into a part of our cosmic neighborhood that's a bit less flashy than Sirius, but just as intriguing. We're talking about Luton 726, 8, a binary star system about 8.7 light-years away. Both stars in this cosmic dance are red dwarfs, much smaller and cooler than our own sun. These stars are so faint, you'd need a telescope to see them from your backyard. Luton 726, 8 has a trick up its sleeve. These two stars are locked in a tight gravitational embrace, orbiting each other every 26.5 years. As these stars whirl around each other, they get closer, then farther apart, like a couple practicing their two-step. When they get real close, their gravitational fields interact in some pretty wild ways. It's a cosmic ballet, a delicate dance of gravity that's been going on for billions of years. One of the most dramatic displays put on by Luton 726, 8 is its tendency to flare. These sudden bursts of energy can make a star shine hundreds of times brighter for a short period. These flares can release tremendous amounts of energy, enough to strip a planet's atmosphere clean off if it gets caught in the crossfire. That's why astronomers are particularly interested in studying flares from red dwarf stars like those in Luton 726, 8. We want to know if planets around these stars stand a chance of holding on to their atmospheres. While Luton 726, 8 might not be the most glamorous destination, it's a reminder that even the faintest stars can hold secrets and surprises. As we continue to explore the universe, we're bound to find even more strange and wonderful objects out there. We're about to visit a star known for its temper tantrums. Ross 154, another red dwarf star just 9.7 light-years from Earth. This little fella is a firecracker, known for its sudden and intense flares that can make it shine up to 10 times brighter for a short spell. These flares are caused by the star's magnetic field lines getting tangled and then snapping, releasing a tremendous amount of energy. Imagine being on a planet orbiting Ross 154 when one of these flares erupts. It would be like being on the surface of the sun for a few minutes, with temperatures soaring high enough to melt lead. But here's the thing about Ross 154's flares. They're not predictable. They can happen at any time, with no warning, like a cosmic game of Russian roulette. One minute, everything's quiet and peaceful, and the next minute, bam! You're caught in a stellar inferno. With all those flares going off, surely there can't be any life around Ross 154. Those flares would certainly make it challenging for life as we know it to survive on any planets that might be orbiting this volatile star. But life is surprisingly resilient. We've found life here on Earth thriving in some of the most extreme environments imaginable. So who's to say that life couldn't find a way to adapt to the challenges posed by a flare star, like Ross 154? Maybe there are planets out there with thick atmospheres that can shield their surfaces from the worst of the flares. This little star is a fascinating target for astronomers searching for signs of life beyond our solar system. Let's turn our attention to a star that's a bit of a homebody, at least for now. We're talking about Ross 248, a faint red dwarf star currently about 10.3 light-years away in the constellation Andromeda. This star is on the move, folks. It's what astronomers call a high proper motion star, zipping through space at a relatively fast clip compared to its neighbors. In about 36,000 years, Ross 248 is going to make a close pass by our own solar system. It will be closer to us than Proxima Centauri is now. 36,000 years is a long time, but it's interesting to think about a star other than our sun being the closest star to Earth. It's a reminder that the universe is a dynamic and ever-changing place. What happens when a star gets close to another star? It all depends on how close they get and how massive they are. In the case of Ross 248 and our own sun, it's not going to be a cataclysmic event. However, this close encounter could still have some interesting effects. The gravity of Ross 248 could stir up the Oort cloud, sending a shower of comets hurtling towards the inner solar system. Even if Ross 248 were to send a few comets our way, it's not like we'd be caught off guard. Astronomers are keeping a close eye on this star, and we'd have plenty of warning if anything were headed our way. It's a reminder that the universe is a dynamic and ever-changing place. We're about to visit a star that's a bit of a youngster compared to some of the old-timers we've encountered so far. We're talking about Epsilon Eridani, a star that's practically a whiz kid in astronomical terms, clocking in at a mere 800 million years old. Epsilon Eridani is a bit farther out than some of our other stops, about 10.5 light-years away in the constellation Eridanus. This star is bright enough to be seen with the naked eye on a clear night, shining with a soft orange-yellow hue. Epsilon Eridani is a main-sequence star, just like our own Sun, but it's a bit smaller, cooler, and less massive. And just like a young'un, Epsilon Eridani is still surrounded by a lot of dust and debris, the leftover remnants from its formation. This dust and debris is a telltale sign that Epsilon Eridani might be hosting a planetary system of its own. And that, my friends, is where things get really interesting. Planets form from the dust and gas that surrounds a young star. It's like a cosmic construction site, with gravity acting as the foreman, pulling together particles of dust and gas into larger and larger clumps. Based on the observations we've made of Epsilon Eridani, it looks like this star has all the right ingredients for planet formation. Astronomers have detected at least 2 debris disks around the star, one inner disk closer in and one outer disk farther out. We haven't actually spotted any planets around Epsilon Eridani yet, but that doesn't mean they're not there. Epsilon Eridani is a prime target for future telescopes and missions designed to search for exoplanets. The search for other worlds is just getting started. We're heading down south now, astronomically speaking. We're going to visit a star that's a bit of a hidden gem tucked away in the southern celestial hemisphere. I'm talking about Lacaille, 9,352, a red dwarf star about 11.5 light-years away in the constellation Piscis Austrinus. Lacaille 9,352 might not be the brightest star in the sky, but it's got a certain charm, like a firefly blinking in the dark. This star is actually moving closer to us. In about 31,000 years, Lacaille 9,352 will be the closest star to our Sun, even closer than Proxima Centauri is now. Lacaille 9,352 is a relatively well-studied star, and astronomers have learned a lot about it over the years. It's a reminder that the universe is full of surprises, and that even the faintest stars can hold secrets and surprises. And by surprises, I mean planets. Astronomers have been searching for signs of planets around Lacaille 9,352 for years. They detected a slight wobble in the star's motion, suggesting an unseen planet. This wobble was extremely small, like trying to measure the width of a human hair from a mile away, but it was enough to get astronomers excited. Unfortunately, further observations failed to confirm the existence of this planet. It seems the wobble was just a cosmic mirage. The search for planets around Lacaille 9,352 is far from over. With new telescopes and techniques, we're getting better at detecting these elusive worlds. The universe is full of surprises, folks, and that's what makes exploring it so exciting. Now, let's mosey on over to a star that's a bit of an introvert. We're talking about Ross 128, a red dwarf star about 11 light-years away in Virgo. This little fella is pretty faint, even for a red dwarf. But don't let its dimness fool you. Ross 128 is a fascinating star in its own right. It's what astronomers call a quiet star. That means it doesn't flare up as much as some of its red dwarf cousins. So, a star like Ross 128 is seen as a more promising place to search for habitable worlds. Now I know what you're thinking. Crixus, are you telling me there might be planets around this quiet little star? There have been some intriguing hints, whispers in the cosmic wind. In 2017, astronomers detected a faint signal from Ross 128. It could be a planet orbiting the star. But it needed further confirmation. They pointed their telescopes, eager to learn more. Follow-up observations haven't confirmed the planet, but don't despair. The search is far from over. Maybe one day we'll find proof of a planetary system, maybe even life. Well, folks, we're about to dive into a system that's a bit crowded, even by cosmic standards. I'm talking about Easy Aquarii, a triple-star system in the constellation Aquarius. Did you notice it? Triple-star systems are rare compared to single or binary stars. With 3 stars dancing around each other, things get wild and unpredictable. All 3 stars in Easy Aquarii are red dwarfs, smaller and cooler than our sun. They're so close together they'd fit inside Jupiter's orbit in our solar system. The three stars in Easy Aquarii are locked in a complex orbital dance, with two of the stars, Easy Aquarii A and C, orbiting each other very closely, and the third star, Easy Aquarii B, orbiting the AC pair at a slightly greater distance. It's like a cosmic waltz, folks, with three partners instead of two. Now, astronomers have been studying this stellar dance for years, and they've learned a lot about the dynamics of triple star systems. They've discovered that the orbital periods of the stars in Easy Aquarii are very short, with A and C orbiting each other every 3.8 days, and B orbiting the AC pair every 823 days. That's right, folks. A year on Easy Aquarii B is only a little over 2 Earth years long. Now, you might be thinking, Crixus, with those stars all whipping around each other so fast, wouldn't they just fly apart? And that's a fair question. But here's the thing about gravity. It's a powerful force, especially when you've got three stars all pulling on each other at the same time. So, even though the stars in Easy Aquarii are moving pretty fast, their mutual gravitational attraction keeps them bound together in a cosmic ballet that's been going on for billions of years. And as astronomers continue to study this fascinating system, they're learning more about the intricate dance of gravity and the formation of multiple star systems. Let's mosey on over to a star that's a bit more solitary, but no less fascinating. We're talking about Procyon, a bright star about 11.5 light-years away in the constellation Canis Minor. Procyon is like Sirius's little brother, not as bright, but still prominent. You can see it shining with a soft yellowish-white light on a clear night. Procyon is actually a binary star system with a faint companion star. Now, Procyon A and B are locked in a tight gravitational embrace, orbiting each other every 40 years or so. It's like a cosmic dance, folks, with one partner shining bright and the other barely visible, but both equally important to the overall performance. And just like any good dance partners, Procyon A and B have a few secrets up their sleeves. You see, astronomers have been studying this stellar couple for years, and they've discovered that Procyon B is a lot more massive than they initially thought. Now, white dwarfs are already pretty dense objects, but Procyon B is a real heavyweight, packing a lot of mass into a very small space. In fact, it's one of the most massive white dwarfs known, which means it must have started out as a pretty hefty star before it went through its death throes. Astronomers are still trying to figure out exactly how Procyon B got to be so massive, but they suspect it might have something to do with the way it interacted with its companion star, Procyon A, billions of years ago. Now, the study of Procyon and its companion has provided astronomers with valuable insights into the evolution of stars and the nature of white dwarfs. It's a reminder that even the most familiar stars can hold secrets, and that there's always more to learn about the universe around us. Well, folks, we're off to visit a star that holds a special place in astronomical history. This ain't about the brightest star or the closest, but a star that whispered a secret to us. I'm talking about 61 Cygni, a rather unassuming star in the constellation Cygnus. It's a binary system, two stars bound in a gravitational dance. Back in the 1830s, Friedrich Bessel noticed something peculiar. 61 Cygni had a little wobble, a slight deviation from that straight and narrow path. He figured that something must be tugging on 61 Cygni, some invisible companion. And what he found, well, it was nothing short of revolutionary. Bessel's calculations showed that the unseen companion to 61 Cygni wasn't another star, but something much smaller, much fainter. He had discovered the first evidence of an exoplanet, a planet orbiting another star, whether it was a giant ball of gas or a small rocky world like our own. His discovery sent shockwaves through the scientific community. It was like finding a footprint in the sand and realizing you're not alone. In the decades that followed, astronomers discovered thousands of exoplanets. So the next time you look up at the night sky, remember 61 Cygni, a secret that opened our eyes to a universe teeming with planets. Even the smallest wobble can lead to the greatest discoveries.
Well, we're journeying now on over to the constellation Draco, the Dragon, to visit Struve 2398, a binary star system about 11.5 light-years away. Just two faint reddish points of light, like a couple of embers in a cosmic fireplace. Both stars are red dwarfs, smaller and cooler than our sun. And just like a pair of dancers, these stars are locked in a graceful waltz.
Flares are sudden, intense bursts of energy that make a star shine hundreds of times brighter. Struve 2398 is known for its energetic outbursts. Both stars in this system are classified as flare stars. These flares are caused by intense magnetic fields around red dwarf stars. When magnetic fields snap and reconnect, they release tremendous energy. Flares could make life rough for any planets orbiting Struve 2398. Studying these flares helps us understand the magnetic activity of red dwarf stars. It's another piece of the puzzle in understanding the cosmos. We're sidling over to Andromeda to visit Groombridge 34, a binary star system. It's about 11.6 light-years away. You won't find it shining bright, even on clear nights. Both stars are red dwarfs, pretty darn faint. You'd need a decent telescope to spot them. But Groombridge 34 has secrets worth a closer look. Now, one of the most tantalizing questions about Groombridge 34 is whether or not it has any planets. You see, folks, red dwarf stars are the most common type of star in our galaxy, and they're known to be relatively stable and long-lived. This has led some astronomers to believe that red dwarfs might be ideal places for planets to form and for life to potentially arise. And so astronomers have been scouring the vicinity of Groombridge 34, looking for any telltale signs of planets. They've been looking for wobbles in the star's movements, dips in their brightness, anything that might betray the presence of an unseen companion. And in 2016, astronomers announced that they had found evidence for not one but two planets orbiting Groombridge 34A, the slightly larger of the two stars in the system. Now, these planets, if they exist, are likely quite different from the planets in our own solar system. One is thought to be a super-Earth, a rocky world larger and more massive than Earth, while the other is thought to be a mini-Neptune, a gas giant smaller than Neptune, but still much larger than Earth. Now I know what you're thinking, folks. Crixus, are you saying there might be life on these planets? Well, hold your horses. We're getting ahead of ourselves. We're heading south to visit Epsilon Indi, a star about 12 light-years away in the constellation Indus. It's tricky to spot from the northern hemisphere, but visible down south. Epsilon Indi shines with a soft orange-red glow. It's a K-type star, cooler and longer-lived than our Sun. It might even host habitable planets. In 2003, astronomers made a remarkable discovery. Epsilon Indi has a companion, a faint object orbiting at 1,500 AU. It's a brown dwarf. Not quite a star, not quite a planet. Too small for nuclear fusion, but too big to be a planet. This discovery was a big deal. Well, folks, we're fixing to visit a star that's so faint you'd need a pretty powerful telescope to even spot it. We're talking about DX Cancri, a red dwarf star that's about 11.8 light-years away in the constellation Cancer. It's like trying to spot a firefly in a fireworks display. DX Cancri is what astronomers call a flare star, and those, my friends, are always up for a good show. DX Cancri is known for putting on some real humdingers. A star with a temper. Those flares might be pretty to look at, but I wouldn't want to be caught in one. Imagine being on a planet orbiting DX Cancri during a flare. It'd be like being on the surface of the sun with temperatures soaring high enough to melt lead. DX Cancri's flares are unpredictable, like a cosmic game of Russian roulette. One minute everything's quiet, and the next, bam, a stellar inferno. Even the faintest stars can pack a powerful punch. Well, now let's head on over to the constellation Cetus, the whale, to visit a star that's been a favorite of science fiction writers and astronomers alike for decades. I'm talking about Tau Ceti, a star that's practically a household name, even if you're not a space enthusiast. Now, Tau Ceti is about 12 light-years away, making it one of the closest sun-like stars to our own. And by sun-like, I mean it's a main sequence star, just like our own, with a similar mass and temperature. It's like finding a long-lost cousin out there in the vastness of space, a star that reminds us of home, even though it's trillions of miles away. Now, you can't actually see Tau Ceti with the naked eye, at least not from most parts of the world. It's a bit too faint for that, kind of like trying to spot a single firefly in a field full of lightning bugs. But with a good pair of binoculars or a small telescope, you can find it shining away with a soft, yellowish-white light, like a distant beacon in the cosmic sea. And for astronomers, that faint light holds a wealth of information. You see, by studying the light from Tau Ceti, astronomers can learn all sorts of things about it, like its temperature, its size, its composition, even how fast it's spinning. It's like being a cosmic detective, using the clues hidden in starlight to piece together the story of a star's life. Now, one of the most intriguing things about Tau Ceti is that it's surrounded by a massive disk of dust and debris. This dust and debris is actually a telltale sign that Tau Ceti might be hosting a planetary system of its own. Planets form from the dust and gas that surrounds a young star. Gravity pulls together particles of dust and gas into larger clumps. Some clumps grow into small, rocky planets like Earth, others into massive gaseous planets like Jupiter. Based on the dust disk, astronomers believe there could be several planets orbiting Tau Ceti. Tau Ceti is a prime target for future telescopes and missions designed to search for exoplanets. Well, folks, we're about to meet a star that's a true testament to the phrase "good things come in small packages." We're talking about GJ 1061, a red dwarf star that's a mere 12 light-years away. GJ 1061 is so faint it's practically invisible without a decent telescope. In fact, GJ 1061 has captured the attention of astronomers in recent years. It's part of our local stellar neighborhood, moving and grooving together through space. Now, one of the most exciting things about GJ 1061 is that it's home to at least 3 planets. That's right, folks. This dim little star has a planetary system of its own, and these planets aren't just any old chunks of rock and gas. They're what astronomers call super-Earths, planets that are larger and more massive than our own Earth, but smaller than gas giants like Neptune. Now, we haven't actually seen these planets directly. They're too close to their star and too faint for even our most powerful telescopes to make out. But astronomers have been able to detect their presence by observing the tiny wobbles they induce in the motion of their host star. It's like trying to figure out if someone's home by watching for the slight sway of their porch swing as they gently push off the ground. It takes some mighty fine measurements and a whole lot of patience, but astronomers are up for the challenge. And the payoff? Well, it could be huge. You see, folks, these super-Earths around GJ 1061 are particularly intriguing because they orbit within their star's habitable zone. That's the region around a star where temperatures are just right for liquid water to exist on the surface of a planet, which, as we all know, is a key ingredient for life as we know it. Well, we've now come to the end of our journey through our stellar neighborhood. We've visited some of the closest stars to our own, from the faintest red dwarfs to the brightest giants. We've seen stars locked in intricate dances of gravity, stars that flare and erupt with unimaginable power, and stars that might just be harboring planets of their own, maybe even planets with the potential for life. We started our journey right next door at the Alpha Centauri system, where a trio of stars waltz around each other in a cosmic ballet. Proxima Centauri b tantalizes us with the possibility of another world in the habitable zone. We've explored the speedy nature of Barnard's star and the potential planetary demise it might have orchestrated. We've delved into the faint flicker of Wolf 359, a star known for its powerful flares. We've marveled at the ancient mysteries held by Lalande 21185, a celestial time capsule that's been around for billions of years. We've gazed upon the brilliance of Sirius, the dog star, and its enigmatic white dwarf companion, a stellar couple with a story to tell about the life and death of stars. We've journeyed to the faint pair of Lighton 726, 8, a binary system that reminds us even the smallest stars can put on a show. We've pondered the potential for life around Ross 154, a flare star with a bit of a temper. Each star, a unique story, a cosmic fingerprint in the vast expanse of the universe. Our galaxy is dynamic and ever-changing, filled with stars of all shapes and sizes, each with its own story to tell. Our sun is just one of billions in the Milky Way, and our galaxy is one of billions in the universe. The scale is mind-boggling, but rather than feeling insignificant, I hope this journey leaves you with a sense of awe and wonder. We live in a universe of incredible beauty, complexity, and mystery. There's still so much more to discover, so keep looking up, keep wondering, and keep exploring the cosmos. Don't forget to like and subscribe. And as always, thanks for